So we did non-permissible values. Non-permissible values never go away. So for every single lesson, you're going to be stating the non-permissible values. So sometimes if people find them hard at the beginning, by the end of the unit, you find it quite easy because we do them on every single question. What we're doing today is we're doing equivalent rationals. So in grade, I don't remember, elementary school somewhere, you were given like often a piece of pie like this. And you would say, this was shaded, and they'd say, it's a pizza. How much of the pizza do you have left? And you'd say 1 out of 2. And then your teacher said, wait, we're going to split that down the middle. Now how many pieces do you have? 2 out of 4. And then they went wild and split it like this. Now how many do you have? 4 out of 8. These are equivalent fractions. They're actually the same, right? You're just now eating smaller pieces of pizza, but you still have the same amount of pizza in the end, correct? So they're equivalent fractions. We're going to be doing equivalent rationals. So we're going to either divide the top and the bottom by the same thing and get something smaller reduced, but still the same. Or we're going to multiply the top and the bottom by the same thing and get something bigger, but still the same. So for example, with this 4 and 8, I could divide the top and the bottom both by 4, and I would get this half. It's the same, correct? Or I could take the 2 over 4, and I could divide them both by 2, and I get a half, which is still the same. Or I could take the half, and I could multiply the top and the bottom by 4, and I'd get 4/8, which is the same. So equivalent, what I have to do is I have to do the same to the top and the bottom, whether it's division or multiplication. Okay? So you can either make it smaller or you can make it bigger. Now some people say to me, well then, on the diploma, how can they ask me for an equivalent if I multiply it by 2 on the top and the bottom, or I divide it by 2 on the top and the bottom, but they multiplied it by 3? How can they do this, right? Well, they could give you multiple choice answers, and you have to try and find one that matches. So figure out what they did to it to make it the same, right? Or if take the multiple choice answers and try and see if you can do something to them to get them to be back to the same as what the question's asking. Or they can give you like a partial one, which I'll show you later. Okay? So write a rational expression that's equivalent to this. So we're going to do one where we divide it out. So what could I take out of all of those terms? What's the same in all of those? Top and bottom. 4x. So I have 4x squared plus 8x over 4x. And Carson said I can take a 4x out of them. So as long as I can do it to the top and to the bottom, it's equivalent. So 4x squared, divided by 4x is x plus sign. 8x divided by 4x is 2, because 8 divided by 4 is 2, x divided by x goes away. Over 4x divided by 4x, 1. Now, x plus 2 over 1, do I have to write the 1 on the bottom? No, every whole number like 8 or 7, you can write over 1, correct? You can make it be a fraction if you want. So this way you don't have to. But if the question had been this instead, 4x over 4x squared plus 8x, and I divided by 4x. Oops, that didn't look like a division. I would have 1 over x plus 2. In that case, do I have to keep the 1? Yes. Because if you're saying that these are the same and you can both just write x plus 2, then you're saying that, like say this was a 7, 7 over 1 is the same as 1 over 7. Is it? No, this is a fraction, right? This is a true fraction where you have to keep the 1. So if you have a 1 in the numerator, you have to keep it. So if you have a 1 in the top in the numerator, you have to keep it. But if you have a 1 in the denominator, you can get rid of it. So in this case, I could just write x plus 2. Okay? Because the 1 can go away because it's in the denominator. Now, another equivalent, what I could do is I could have multiplied the top and the bottom by something. So say I have 4x squared plus 8x over 4x. So equivalent, you can multiply the top and the bottom by something, or you can divide the top and the bottom by something. Okay? It doesn't matter. Simplifying, you have to make smaller, so you have to do division. But equivalence, you can multiply or divide. So I'm going to multiply the top and the bottom by x. You could pick 2. You could pick 3. It doesn't really matter, right? I'm going to choose x. So I'm going to multiply the top and the bottom by x. The only thing that I have to remember is that I have to do it to the entire top and to the entire bottom. Okay? So 4x squared times x is 4x cubed. You add them, right? Because they're the same base. Plus 8x times x is 8x squared over 4x squared. This is also equivalent. So 4x squared plus 8x over 4x is equivalent to x plus 2 is equivalent to 4x cubed plus 8x squared over 4x squared. These are all the same, just like a half is equal to 2/4 is equal to 4/8. Okay? They're equivalent because you're doing the same thing to the top and the bottom. If you only did it to the denominator, so the bottom, and not the numerator, the top, then it wouldn't be equivalent. You have to do it to both. Okay? Now, I told you we're going to be stating NPVs of everything because that's how we get better at it. So I'm going to look at the original denominator, and if I'm stating NPVs, I only care about the denominator. The original denominator is 4x. Are those attached by a plus or minus sign? No. So I can put them in their own separate brackets because they're multiplied. Then I set them not equal to 0. So 4 cannot equal 0. What did I tell you if it's a number cannot equal 0? What do I do? You just cross out. You just cancel it because there's no variable, right? So that one doesn't matter. Then my other one is going to be x can't equal 0. Do I have to solve it out? No, that one's easy. It's literally done for you. X can't equal 0. So the only NPV for this question is x can't equal 0. Make sense? All right. Example 4 wants us to state or to determine, so understand, check, determine, wants us to find out if they're equivalent. The easiest way to do that is take one of them and try and make the other one be it. Okay? So it's up to you. You can either take the second one and make it try and be the first one, or the first one and try and make it be the second one. They have to be the exact same in every single way, so the signs have to be the same as well. So I'm going to try and make the first one be the second one. So I have 9 over 3x minus 1. And I'm trying to make it be negative 18 over 2 minus 6x. So I'm going to compare the monomial to the monomial. So what does that mean? I'm going to compare the top to the top because they both have one term, monomials. Okay? Because it's easier to look at that. So this one is a 9 on the top in the numerator. And I want it to be a negative 18 times by negative 2. Now, when I multiply by negative 2 on the top, I have to remember to do it to the bottom, to the denominator as well, or else it won't be equivalent, right? So we're going to times by negative 2. So I'm going to get negative 18 on the top, looking good so far. And then on the bottom, I have to remember to distribute it. So I get negative 2 times 3x is negative 6x. Negative 2 times negative 1 is positive 2. Now here's the real question. Are they equivalent?
Yes.
They are, even though it's different order. Because the test to see if they're equivalent is, do you have the exact same numbers in the numerator and the denominator with the same signs? They have to have the same signs in front of them. If they have the same signs in front of them, it doesn't matter if they're a different order. So let's check it out. We have negative 18, negative 18. We have negative 6x. We have negative 6x. We have a positive 2. We have a positive 2. So they're equivalent. So they have to be the same number, same sign. Same in the top, same in the bottom. Okay? You guys try B. See how you do. David. So, yo. Which one are you changing? The first one to the second one or the second one to the first one? What'd you do? To the top and to the bottom. You could have went the other way and that'd be fine. So divide by 2, divide by 2. 2 divided by 2 is 1. Negative 2x divided by 2 is negative 1x. And then 4x divided by 2 is 2x. Positive 2x, positive 2x, positive x, negative 1. It's the problem. It doesn't work. So what is it? Not equivalent.
You just put 1x or do you just put x? You just put x.
You could put just x. Yeah. All right. In each case, write a rational expression with a given variable and non-permissible values. So we went over this before. We'll go over it again in your homework. The variable we're going to use is x. The non-permissible value is 3. So that means we had on the denominator x can't equal 3. How can we work that backwards? How can I move the 3 over to the other side?
X plus 3. X minus 3.
We went all around and we finally landed on it. Yes. So we're going to subtract the 3 and we're going to have x minus 3 cannot equal 0. Does it matter what the numerator is, what the top is? No, they didn't give us any specification. So I'm going to put x minus 3 on the bottom, and you can put whatever you want, but if you put a variable, it has to be an x. So you can't put like an m, all right? So I'm going to make it be 6x. You can make it be 6. You can make it be x. You can make it be x plus 7. You can make it be negative 3x squared minus 2x minus 7 million. You could do whatever you want, okay? But no m. B, the variable is a. So we have two non-permissible values this time. We have a cannot equal 0, and we have a cannot equal 4. The a cannot equal 0 is done, right? Because you can't undo that. So that's going to be one of our NPVs. It's just going to be a. So we're on the bottom. We're going to have an a on the bottom. Now we have a cannot equal 4. How do we undo that? It's a positive 4, so we're going to subtract it. So I'm going to have an a minus 4 on the bottom. You could put them together. So like on the diploma, they could technically have a squared minus 4a as one of the answers, and they would be right because they just went the extra step and distributed the denominator. And on the top, I'm going to put an a squared to be fancy. You could put 7. It doesn't really matter. So we're going to look at C. C is the variable is p this time. The non-permissible value is 1/3. So we're going to have p cannot equal 1/3. How do I undo a 1/3? Some people would say, well, I can go p minus 1/3. Yeah, p minus 1/3 is correct, but that answer will never be there. So you actually have to split it up and multiply by 3 first. So you're going to multiply both sides by 3. So then that 3 cancels off. And I'm left with 3p cannot equal 1. You have to do it in steps. You have to, and it's a fraction. Okay, you can't just subtract 1/3. It's not wrong, but the answer will never be there. Now I need to move the positive 1 over. How can I do that? Minus 1. So I'm going to get 3p. I'm going to subtract 1 from both sides. 3p minus 1 cannot equal 0. So this is my NPV, 3p minus 1. So on the bottom, I'm going to have 3p minus 1. And on the top, I could just have like a number, like 7. Or I could be fancy, and I'm going to go 2p plus 7. Okay, try D. So we have m cannot equal negative 8. How do I move the negative 8 over? I add 8. So I get m plus 8 cannot equal 0. So m plus 8 is my NPV. So I could have 12 over n plus 8. All right?
Oh, wow.
Did you do the same thing? Good job, Xavier. David. David. Oh, this is good. I'm going to I know what I'm going to do. Simplifying is basically almost the same as equivalent, except with equivalent, you can actually multiply the top and the bottom by the same thing, right? You can make it bigger. Simplifying, you're simplifying. You're making it more simple. So you're not going to multiply the top and the bottom by the same thing because that wouldn't make it more simple. That would make it more complex. So simplifying, we have to do the same to the top and the bottom through division. You're making it smaller. So you have to divide something out of the top and the bottom. That's the same. Okay? So the first thing with simplifying that I always do, and I'm going to do this with simplifying or multiplying and dividing, all the rationals, the same thing. You're going to go to the numerators and the denominators, the tops and the bottoms, and you're going to factor them or GCF. Okay, so difference of squares of GCF is what you're going to do the tops and bottoms first. Then we're going to state NPVs, because you never ever cancel off until you state your non-permissible values. Because if you cancel off first, then state non-permissible values, you could cancel off something out of the bottom and you'll miss a non-permissible value. Okay? So you always state non-permissible values before you go to cancel anything. I know you'll get excited. You'll be like, yes, I can take this out of the top and the bottom. But stop yourself and state NPVs first. Because on the diploma, they'll always give the answer to the NPVs after they're canceled. And that's a common error, right? We don't want to get an NPV question wrong, because those are the easy ones on the diploma. So, express the following rational expressions in simplified form, stating the non-permissible values as restrictions. So on the top, we have 12x squared. I'm going to write them out in brackets, okay? Because they're not attached by plus or minus signs, correct? So I have 12 in brackets, so this equals 12, and x squared in brackets. And then on the bottom, I have a 2 and an x. Now I can say to myself, what can I take out of them? But before I cancel anything off, what do I have to do? State NPVs. So I have my NPVs here. I would have 2 can't equal 0. But I don't worry about that one because there's no variable. Yeah? And the other one would be? X cannot equal 0. So the only NPV here is x can't equal 0. Then I say, what can I take out of the top and the bottom? And it has to come out of the top and the bottom. So when I say take out, what I'm actually meaning is you're technically, when you're taking something out of them, you're dividing that same thing out, correct? So what can I divide out of 12 and 2? I have just 12 and 2. Yes. So out of 2, I can go 2 divided by 2, and I'm left with a 1. I can do 12 divided by 2, and I'm left with a 6. And then you said for x's, x squared and x, I can take out just one x, right? I have to take out the smallest. So an x out of x, I'm left with a 1. X squared out of x, x out of x squared, I'm left with just an x to the 1. So on the top, I'm left with 6 times these. When you cancel these off, these little slash lines are actually 1s when you're canceling them off. Remember, they don't become 0s, they become 1s, remember? So this is 6 times 1 times x to the 1. What's 6 times 1 times x to the 1? 6x. And then on the bottom, I have 1 times 1 times 1 times 1. 1. Do I have to write the 1 if it's in the denominator? No. So I can write it as 6x. And then I can follow behind x cannot equal 0, because that's my NPV. And that would be my answer. Make sure you're copying the notes. Yeah.
We're copying notes. You want to fill out like different things as you write it down or just write down?
Well, true that. Thank you. That was easy. Okay. B. So GCF or difference of squares if I can, but these are already nicely put in brackets. If you get something like this on the diploma, you should be like doing cartwheels. You should be so excited because they've nicely broken it down for you. Breaking it. That doesn't even make sense. So I have a minus 7 and a plus 1 in the denominator. Do I care about the top two for NPVs? No, just the bottom. So I'm going to say for my NPVs, x minus 7 cannot, it's not an x, it's an a minus 7 cannot equal 0, and a plus 1 cannot equal 0. So when I move that 7 over, I'm going to add it. So I'd have a cannot equal 7, and then I'm subtract 1. A cannot equal negative 1. So those are my two NPVs, which I'll state at the end once I've simplified it. I always state NPVs before I cancel. So if you're someone who's going to want to cancel, then state NPVs, you should put a little star in your notes saying, don't state NPVs. State NPVs before canceling. So don't cancel, then state NPVs. So make sure you state your NPVs before you cancel anything off. Okay? Now, this is where I get some craziness in grade 10 sometimes, when I give stuff like this in grade 11. I get some crazy canceling. So what you do is you have to remember that you need to have exactly the same thing in order to cancel it. Okay? If there's plus or minus signs between it, we actually put brackets around those, right? So here we have a plus 1. It is bracketed. So the only way that a plus 1 is going anywhere is if you have an a plus 1 in the denominator. Okay? It has to match exactly. You cannot do this. You can't go a for a for a, 1 for 1. You can't do that. A plus 1 is attached. It's sewn together. It's like one human being. Okay? It's like a plus 1 is one thing. It's only going anywhere if you can do that. If not, if you cross this a off with this a, you just decapitated two human beings. Like, you should feel really bad about yourself. Right? That's quite terrible. So we don't want to be that person. You're also going to get the question wrong, which is also bad. Not even a smile. All right, good. A plus 1 cancels off a plus 1. Can those a's cancel? Yeah, you just decapitated. Not good. So we can't cancel this a off with this a. This is an a minus 6. It's only going away if there's an a minus 6 in the bottom. Is there? No. A minus 7. It's only going away if there's an a minus 7 in the numerator in the top. Is there? No. So they're left over. A minus 6 over a minus 7. And then we state behind it, a cannot equal negative 1, comma 7. Does that make sense? C is a bit of trickery. So before I cancel anything off, I want to take out NPVs if I can. I could take a what out of the top? A 2. Some people are like, sweet, 8y, 8y. Can we do that? No. To stop yourself, whenever you have something with a plus or minus sign in the question, always put brackets around it right away so that you know it's attached, to stop yourself from trying to cancel those 8y's off. I get that happening all the time. People cancel the 8y's off, tell me it's 2, and they're just super happy. You're super wrong. So you shouldn't be super happy, but you are. Do not cancel that 8y off with that 8y. Okay? Actually, the 8 and the y are separate because they're multiplied. So I actually right now have 8y plus 2 in its own brackets, and then I'd have an 8 and a y in its own brackets because they're multiplied together, not attached by plus or minus signs. The top I could take out a GCF of 2. When I take a 2 out, I'm left with 8y divided by 2, which is 4y, plus 2 divided by 2, which is 1, over 8 times y. That 2 is in its own brackets because it's being multiplied. Whenever there's multiplication, you can put them in brackets. Before I go to cancel the 2 and the 8, I have to state NPVs. Remember, before you go to cancel anything off, you have to state NPVs. So my NPVs are based on my denominator. So 8 can't equal 0, which doesn't get me an NPV because there's no variable. There's no letter. And then the other one would be y can't equal 0. Once I stated NPVs, I can cancel. So out of the 2 and the 8, I can take a what? A 2. And I can take it out of both of those because they're in their own separate bracket, right? There's nothing attached to them. I can cross them off. Can I cross this 4 and this 8 off? No. This 4y plus 1 is one human. Okay? Unless there's a 4y plus 1 in the denominator, that baby's not going away. Is there a 4y plus 1 in the denominator? No. So I know my answer is going to have a 4y plus 1 in the numerator because there is no matching on the bottom. It's not going to go away. Don't try and cancel anything out with it. Okay? So 2 divided by 2 is 2. 8 divided by 2 is 4. Can I cancel this y off with this y? No. This is 4y plus 1. It is only going away if there's a 4y plus 1 in the denominator, and there isn't. So it's not going to get any better than this. This is 1. Wow, that's sad. 2 divided by 2 is 1. Do I have to write that 1 in front? It's 1 times something. Do I have to write it? No. So it's 4y plus 1 over 4y. What are people going to want to do? Cross out the 4y's. Can I? No. This is 4y plus 1 together. It can't go away because it doesn't have a 4y plus 1 on the bottom. Make sense? You see how that's an error that people will do all the time? Don't be that person. D. I have negative x plus 7 in the numerator. And what's the bottom? The difference of squares. So the square root of 49 is 7. And the square root of x is x. And I have a subtraction sign between. So because they're both perfect squares and I have a subtraction sign between, it's a difference of squares. So I'm going to get 7 plus x, 7 minus x. Make sure if your phone's out, it's not. 7 minus x, 7 plus x. All right. Now, before I try and cancel anything off, I have to state non-permissible values. Okay? So I'm going to go off to the side, and I'm going to go 7 plus x cannot equal 0. So x cannot equal negative 7 because I'd have to subtract the x, or subtract the 7. And then I have 7 minus x cannot equal 0. Instead of moving the 7 over, what could I just do? Just add the x. So 7 cannot equal x. So my NPVs are x cannot equal 7 with a plus or minus sign in front. Now this negative x plus 7 up here is also in brackets because it's attached, correct? The only way I can cancel if they're the exact same signs. So do they have to be in the exact same order? No, but they need to have the same signs. So on the top I have negative x plus 7. In the bottom, do I have any negative x's plus 7? Yeah. This right here is negative x plus 7. This right here is negative x, and this is a positive 7. So they're actually the same. What did I tell you when I cancel these off? What are those actually? Ones. So am I left with a 0 in the top? No. What am I left with on the numerator in the top? A 1. So I actually have 1 over 7 plus x. Could I go 1 over x plus 7? Could that be an answer? Yeah. You can rearrange them as long as the right sign's in front. And then you'd have behind this x cannot equal plus or minus 7. Do you see now if I state NPVs at the end, I'm going to not have the minus 7, right? And then I would be wrong because I wouldn't have all the NPVs. You guys try E and F. So the first thing we always do is GCF a difference of squares if possible, into the top and the bottom. The moment you know when to write NPVs is when the moment you think, hey, I can cancel these, you stop yourself and you state NPVs before you go to cancel. So you always do GCF and difference of squares first. Once you have everything all simplified down into what the lowest you can do in the top and the bottom, then you state non-permissible values, then you cancel. Okay? So in the top, in the numerator up here, I can take out a 4 and a p. 12p squared divided by 4p is 3p minus sign. 8 divided by 4 is 2. P divided by P cancels. Now that 4 and that P, because there's no plus or minus sign in between them, I can put them in brackets. Okay? 6P cubed minus 4P squared. I can take a 2P squared out. Six divided by 2 is 3. P cubed divided by P squared is P. Minus 4 divided by 2 is 2. P squared divided by P squared is this. So you see these match, and you automatically try and cancel them because you're just so excited that something matches. You're like, I'm doing this right. Stop yourself. You have to say NPVs before you cancel them, okay? And the 2 and the P squared are not attached by plus or minus signs, so we can put them in brackets. So now we state NPVs before we cancel. We have P squared. Remember what I told you if it was P squared or P cubed or P to 700? What's the NPV for that? 0. Okay? So, oh, marker's still thinking. So we'd have 2 cannot equal 0, which we don't have to worry about. We have P squared cannot equal 0, which technically would be P cannot equal plus or minus the square root of 0. When you take the square root, you have to have plus or minus sign, which is just 0. So remember I told you it's P, P squared, P cubed, P4, P700, P to the power 700. It's just 0, right? And then we have 3P minus 2, which is a little more complicated. So we have 3P minus 2 cannot equal 0. We're going to add our 2. We have 3P cannot equal 2. Divide by 3. And P cannot equal 2/3. So those are our two NPVs. The 2 didn't get us 1. And now we say, what can we cancel? So it has to be brackets and brackets, right? So 3P minus 2 matches 3P minus 2 in the numerator and the denominator, so the top and the bottom, so they cancel. If you have a P and a P squared, can they cancel? Are they separate human beings? No. Remember P squared, what is P squared? 2 P's, it's just P times P, correct? So if that's better for you to understand it, instead of writing P squared after, you could have wrote this out as P and P. And then people will see, hey, I can cancel one of them off. Okay? If you can't spot that P squared and P, you can actually take a P out of both. You could rewrite P squared as P and P. Does that make sense? And then you can cancel them if that's easier for you. And then 4 and 2, I can take a 2 out. So 2 divided by 2, I want to write a 2 again. Oh my goodness. 2 divided by 2 is 1. 4 divided by 2 is 2. And so I'm going to get 2 times, and each of these are 1s, right? So 2 times 1 times 1 times 1 is 2. Over 1 times P times 1 is just a P. And so then I have P cannot equal 0 or 2/3. For F, I said what you can do is you can take a 3 out, right, out of the top. Then you take a 3 out, a GCF. You're going to be left with 3, and then T squared minus 25. All over T plus 3, T minus 5. What is T squared minus 25? A difference of squares. So I'm going to be left with 3, bracket, bracket. Square root of T squared is T, so it goes to the front. Square root of 25 is 5, so it goes to the back. And then negative positive or positive negative, doesn't matter. And then on the bottom I have T plus 3 and T minus 5. They will have the answer to the NPVs once you've canceled them off and state. It's wrong, but they'll have that answer there. So make sure you always state NPVs right before you go to cancel. Right now I can see that I can cancel the T minus 5s off. Not going to do that. I'm going to say NPVs first. So I get T plus 3 cannot equal 0, and T minus 5 cannot equal 0. Subtract 3. T cannot equal negative 3. Add 5. T cannot equal 5. Now, most people are really good at this. What's the error that you think people do next? There's a 3 in the top, there's a 3 in the bottom. I can cancel them off. I'll just have a t. Can I do that? No. This is t plus 3. Is there a t plus 3 in the top? No, so it's never going away. T plus 5. Is there a t plus 5 in the bottom? No, so it's never going away. The problem, the biggest error is that people try and make it more simplified than it actually can be. It's not always just t or 7, okay? It can be complex, and that's fine. So it's 3 t plus 5 over t plus 3. And then you'd have t cannot equal negative 3 and 5. I ran out of room. Those should be beside the not equal sign. All right? So we'll do textbook questions tomorrow, but I'm going to have you circle questions that are due for tomorrow, and I'm going to come and check these as well. I'm checking the homework from yesterday during your quiz, and I'm going to be checking to see if you completed these, and we're going to go through the answers tomorrow. Okay? So you circle. Oh my. Only in your class. I don't do this in other classes. I get frustrated, I guess, and want a hip check. Actually, that's not a hip. That's a thigh check. Thigh check that thing. Okay. Oh, I recorded that. You're welcome. You can listen to that later. A, B, C. Circle those 3. So I'm going to check up to example 3 if you've completed up to B. There's more, but I want you to just complete up to B. Okay? So get working.